Hello and welcome to this FortiADC's video on the tunneling packet forwarding mode in Layer 4 deployment. FortiADC is Fortinet's application delivery controller solution that provides Layer 2, Layer 4, and Layer 7 load balancing, SSL offloading, application acceleration, web application security, global server load balancing, etc. In this session, we'll walk through the tunneling packet forwarding mode in Layer 4 deployment, how FortiADC processes traffic in this mode, the benefits it offers, and how to configure it effectively. In Layer 4 deployments, FortiADC is configured with a VIP that clients target instead of communicating directly with real servers. It inspects packets at the IP and TCP UDP header level, and depending on the forwarding mode, it can modify the destination and source IP addresses. This allows FortiADC to support flexible packet forwarding methods, including DNAT, full NAT, direct routing, NAT4.6, and tunneling, making it suitable for complex network topologies, NAT environments, and multi-subnet architectures where direct routing isn't feasible. In the tunneling mode, FortiADC encapsulates client traffic in an IP over IP tunnel and adds a new outer IP header, while the inner payload remains as the original client packet. When the backend server receives the tunneled packet, it decapsulates it and sees the original client packet. Then it sends response directly back to the client. In tunneling mode, the VIP configured on FortiADC to receive client requests must also be configured on each backend server as a loopback interface. This VIP must not respond to ARP requests, because FortiADC is responsible for answering ARP requests for the VIP. This setup ensures proper traffic redirection without IP conflicts. As discussed, using the tunneling packet forwarding mode offers several advantages. First, connections between FortiADC and the backend resources are encapsulated, ensuring secure transmission of traffic across untrusted or public networks. This deployment model is particularly well suited for scenarios where backend resources are located in distributed, cloud-hosted, or geographically distant environments, and FortiADC must traverse public or external networks to reach them, while still maintaining the integrity, confidentiality, and reliability of the data exchange. Second, it allows application servers to see full client details without relying on headers like X-forwarded for. Please note that while powerful for cross-network or hybrid cloud deployments, tunneling mode is relatively uncommon and may introduce complexity in routing, monitoring, and troubleshooting. In addition to tunneling mode, FortiADC supports full NAT, DNAT, NAT4.6, and direct routing modes to accommodate various network topology requirements. Watch the related videos for detailed explanations of each mode, and refer to the network architecture guide available on the FortiADC documentation page for further information. Thanks for watching.